All right, we've added rational functions, and subtracting is a lot like adding, so we're just going to take a quick look at subtracting rational functions. All right, here's our first problem in subtracting rational functions. We already have like denominators, so the only thing that I need to factor this for is to find the restrictions on my variable. So I'm going to factor out a 2, and that gives me m squared minus 1, which is a difference of squares, so I have 2, m plus 1, m minus 1, and that makes the restriction on my variables m not equal to minus 1 or 1. And that's important for our final answer. So now I just need 4m plus 5 minus, and here it's important to keep parentheses because I need to subtract all of this, not just the 3m plus 2 all over 2m squared minus 2. And I need to distribute this negative sign. So I have 4m minus 3m is m, and I have 5 minus 2 is minus 3 over 2m squared minus 2, m not equal to negative 1 or 1, and there is my final answer. Let's go on to the next problem. Right, for this problem, I do not have common denominators, and just like adding fractions, I can't subtract them without a common denominator. Let's set up the exclusions on our variables, and then we will set up common denominators. Here, my restriction is going to be n not equal to 0, and here we have n cannot be equal to 3. So we have that set up so we can work with it. There are no common factors here, so I am just going to need to multiply 2 over 5n squared by 1 in the form of n minus 3 over n minus 3. And I'm going to need to do the same for the other side, multiplying by 5n squared to get into a common denominator. Oops. We have our n minus 3 to start with, and then our 5n squared. That's going to give us a common denominator of n minus 3 times 5n squared. So let's multiply all of this out. I have 2n minus 3 minus, let's remember our parentheses, 25n squared. In this case it won't matter because there's nothing to distribute to, over 5n cubed minus 15n. Now, I can just rearrange these terms to minus 25n squared plus 2n minus 3, but I'm going to factor a negative 1 out of that because I like my leading coefficient to be positive. So that gives me 25n squared minus 2n plus 3, factored a negative out of each of these, all over 5n cubed minus 15. Notice that when I factored negative out of each of these, out of here, out of here, and out of here, it landed here, so we didn't change the value of the function, and that gives us a final answer right here with, let's not forget, n not equal to 0 or 3. So let's just box that right in there as well. There's your second problem for subtracting rational equations. One last problem, once again no common denominator, so let's factor this. We get 2n plus 1. But hey, that's going to be really convenient because that's over 2n, so we can cancel the 2's, reducing this fraction and making our subtraction a little easier. Our restriction on the variable n is not equal to negative 1. So let's work with this much easier expression here as we set up our common denominators. I have n times n plus 3 over n plus 1 times n plus 3. So I have my multiplication by 1 here and here, minus 5 times n plus 1 over n plus 3 times n plus 1. Once again, multiplying only by 1, so I'm not changing any of the values. If we go multiplying this out, I have n squared plus 3n minus, and make sure we distribute this negative sign. It's going to go with our 5 as we distribute. Minus 5n minus 5 all over n squared plus 4n plus 3. And let's not forget our variable restriction here. N's not equal to negative 3. Very important. So now we just need to collect up our like terms. N squared minus 2n minus 5 all over n squared plus 4n plus 3, and not equal to negative 1 or negative 3. And there's our final answer. You can do the last problem here yourself and the problems on the other side.